Hello, I welcome you all. The problem reads, the catapulting mechanism is used to propel the 10 kg slider A to the right along the smooth track. So by this we mean no friction, okay, smooth, no friction. The propelling action is obtained by drawing the pulley attached to the rod BC rapidly to the left by means of a piston P. If the piston applies a constant force F equal to 20 kilonewtons to the rod BC such that it moves 0.2 meters, determine the speed attained by the slider if it was originally at rest. Neglect the mass of the pulleys, cables, piston, and the rod BC. This problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. There are a lot of ways to solve this particular problem, but in this particular chapter we are using the work and energy principle. So if you want to, you can section this, okay, you just need to ensure that you know the displacement of this particular point with respect to C, or if you want, you can work on the whole system, which I'm going to do. Right, so let's draw the free body diagram. So I have the normal force there, like so, and I do have the weight, okay, like so. So that is the weight, and this is the normal force. All right, so using the principle of work and energy, so I'll say the kinetic energy, the initial kinetic energy of the slider, okay, of the slider, I'll use 1 plus the total work done by the slider from point 1 to point 2 is equal to the total kinetic or the final kinetic energy. Alright, so let's write down what we have. Mind you, the piston moves to the right, to the left. Okay, so this is originally at rest, therefore the kinetic energy, initial kinetic energy of the slider is 0, okay, plus the total work done by the whole system. So we do have work done by the piston here, and we have a force in this direction and the displacement in this direction, okay, and this is positive work. So we'll have a force F, okay, so this is equal to 0. The force F times the displacement, let's call it S, okay, S, okay, and then of course positive, then this is just going to be equal to, because we are looking at determining the final speed, this is just going to be equal to half ma times va. Okay, all right, so let's write down this. So we know the magnitude of our force is 20. I'll convert it to newtons, and then we know how much the piston moves is 0.2 meters. All right, and our ma for this slider is 10 kg. Then plugging in everything, then we'll have a 20,000 newtons times 0.2, and this is equal to half times 10 and Va squared, like so, and this is just going to be equal to 20,000 by 0.2, then divided by that, like so. Okay, then we are going to square both sides. And if we did so, then we'll find that our Va is just going to be equal to 20,000 by 0.2 divided by 0.5 by 10, and square root of that, we have a 28.28, and this is in meters per second. Great. So there we go. We've solved this particular problem and found the final speed attained by the slider given these particular conditions that happens. The piston moving to the left by a distance of 0.2, okay, with a force of 20,000 newtons applied to the rod BC. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.